purpose of this tutorial video is to demonstrate how you can use the Texas Department of Transportation Rural Two-Lane Road Segment Safety Score input information to calculate the relevant safety score for an existing, a proposed, a standard, and optimal configuration. The tool is designed to extend up to 15 miles of a quarter in a quarter length. However, this can be shorter, much shorter actually, if one so chooses. You'll also notice that there are two colors used in the input instructions box. The yellow color is intended for text input. The blue color is where one would input information from a list. So this one has an attached list. If I click on the little down arrow, you can see this one has the options of 3R and 4R. If this text, when you use the down arrow, is too small, you can zoom in to that particular part of the tool, and you can look at the down arrow again, and the text should be more visible, like this right here. So you might, might be a challenge, but you might play with that a little bit. For the beginning and ending of a segment, we have beginning mile point and end mile point. The distance or the length between those two is then calculated. You'll see that, for example, this one is one that begins at mile point 2.1 and ends at mile point 5.5, so that's approximately 3.4 miles of section. The tool has been designed to do these evaluations in 1 mile segment lengths. And if you were to scroll down and look at the next section below, you'll see that here we have segments 1 through 4. And you'll see that this begins at segment 2.1 and ends at segment 5.5. And if you were to add these numbers up, this comes up to 3.4. And so this is consistent, of course, with the values that you see in the input box. Now, this is also intended to be relatively intelligent. So if you, for example, had a quarter and instead of ending at mile point 5.5, it would end at, say, mile point 7.2 or so. To be helpful, I typed it correctly, 7.2. Then the tool will realize that instead of having the 4 segments, you now have 6 segments, of which one is a 1/10 of a mile artifact and the rest are 1 mile sections. You'll also notice in this summary table that the applicable worksheet is listed in blue with the exception of the very first option. If you're going to be doing this analysis, we make the assumption you're always going to have one configuration worksheet at a minimum. If you're going to have some sort of controlling element, for example, if the sharpest radius on a horizontal curve is going to be the controlling element for a particular section, then you might want to have a separate configuration tab for this. So you'll notice that this one has the opportunity to do a configuration 2. You also could select a different configuration. I can say, well, I want that one to be configuration 1. You could go all the way down and say, well, ultimately I'm going to have this one be configuration 2. Then maybe I want to have this one be configuration 3. And then what you can do is go into each of these individual worksheets and input those unique characteristics. It's a good starting place. We recommend that you begin with configuration number 1 in all of your locations, and then as you identify what the distinctively different characteristics might be, you begin to populate this table. So there might be a little back and forth if you're working between this and individual configuration tabs. The table at the bottom also has a summary for the length. So it's just added all these up together. In this case, this example is 5.1. And then it has a weighted total score, which captures individual scores identified in the configuration tabs, which we will look at next. For the artifact tabs, for example, this last one had 1/10 of a mile, it'll just weight that value. And then it'll calculate what these scores might be. And this information is output, while the other information to the left of it is input. So this is essentially a summary table to give you that information. So let's go and take a look at this configuration 1 tab. This is where the actual calculations are occurring. You'll notice that at the top we have another input table. There's not a lot of input required for the location or the date because and that's why it's in white. It's because that's pulled from the Start Here tab. We do have characteristic information for location and speed. It does have some warning messages. For example, it will let you know if your postage speed, right now, if I were to zoom in on this, I would see that my postage speed is 55 and my design speed is 65. What if my postage speed had been 70? 70, if I can get that correctly. Down here in this box, it would just simply then give you a warning that the postage speed exceeds the design speed, just to let you know that it's going to be using the larger of the two for the calculations. And hopefully, that might inspire either more conservative geometrics or perhaps a request for some sort of speed limit change if that seems appropriate. Also, up in this input instructions area, you'll see that there's this blue box here. Again, it's blue, so that means it's pulled down. It's got pulled down text. And inside it is existing, standard, design 1, design 2, and optimal. And what this is used for is to display to the right of this a little additional information for whatever alignment or configuration you're looking for at the time. We will come back to that in just a moment. Let's scroll down below and just take a look at what these characteristics look like. We have geometric design elements. If you scroll down below that, you have traffic elements, and further below that is roadside elements. The weighted score is shown. We have about 40 points out of 100 assigned to the geometric design elements, 20 points out of 100 for the traffic elements, and 40 out of 100 for the roadside elements. The reason for this is because the roadside elements, as well as the design elements, the geometric design elements, are more permanent treatments and or improvements. And so we're going to try and give the opportunity to capture how important it is when they're preliminary or initially constructed, because that's something that will have to be fixed at some later date. All right, so we have existing, standard, 2 designs, and optimal. We have an extra column here. What it does is it just helps us do some comparisons between some of the options we have and compare them to standard. So let's say, for example, I was wondering, is 10, a shoulder width of 10 going to be better than a shoulder width of 8, which is going to be the standard here. And what this would do is just do a raw comparison of what it expects you would have as far as improvement in safety. We're going from 8 to 10. If that were the case. Now, of course, I'm just pointing at a different one than this is necessarily reading, but that's kind of what this column is for. We'd like some input from the council on whether or not y'all think this column needs to be displayed. We've set it up so we can hide it if we want to, so it'll be interesting to get that kind of feedback. Another issue is sometimes you have a horizontal curve and sometimes your corridor is primarily on tangent. And so when that happens, you may not need to have input for radius or input for length of curve. You may not need to have vertical curve data information if really all you have is a straight grade. So these are also set up to be no. So if I say no, there's no horizontal curve, then it doesn't ask me for any more horizontal curve information, and the calculations have set that to where it's not going to affect the answer. Same thing with vertical curve. If I say it's no, you'll see that it hides everything. A road should have some sort of a grade on it, so we have maintained the approach grade G1, but otherwise it has eliminated all of the calculations for the vertical curvature conditions. Let's change this one back to yes for a moment. I'm going to keep horizontal curve present to no for just a second because I want to go down and take a look at traffic elements. For traffic elements, we have a variety of typical treatments that you might consider. We also have 3 that are grayscaled out. So these 3 are grayscaled out because they are related to horizontal curvature. And because I held it no up here in the geometric design element, it decided that I didn't want those 3. If I were to change this to yes, and again that would assume I have a horizontal curve, then I see that it's in the traffic elements, those 3 are now active and available to be edited. The roadside elements has an additional box below it. It's set up the same way as the others, but it has an additional box below it. And this box down here, the additional side slope information, just is set up so that if a user is designing a side slope in such a way that, when they say widen the road or something, it's going to push the side slope out into the right of way. It gives you some additional warning about that. It's not a calculation that affects the score. It's just to give the user some information, because you might want to pay attention to whether or not there's a need for right of way acquisition. Under each of these elements, you'll see finally that there's two scores. There's the summary score for the particular design elements. We call that the partial score for that particular element. And then there's the total score. So 74, for example, for existing is consistent on all three of these. And then the score above it, 13. This means 13 out of 20 for the traffic elements. Below that would be 21 out of 74, or excuse me, 21 out of 40, excuse me, for the roadside elements for total 74. So that's kind of, in a nutshell, how these three work. Now, I'm going to zoom out so you can see what the larger page looks like for a moment, because there are two additional elements in this larger page. Up to the upper right, you see what looks like a little, we call it the vortex diagram, which gives you a little additional information if you're making decisions. If you're a design engineer, you're making decisions about what you want to do, which element would have bigger bang for the buck, so to speak, in safety, then that's where you would use that. And then below that, there's a list that just shows basically the geometric characteristics, what the dimensions are, and then a summary for that particular select option. So I told you we were going to come back to this little blue box right up here. So let's do that now. So I'm going to zoom back in. And you can see that currently it's set at design 2. So let's change that to some other value. Of course, we don't really know what values we have down in our screen here, so we're just picking one of these at random just to demonstrate this. You'll notice on design 2, it tells you that you have some treatments that will dramatically improve the opportunity to reduce crashes. You have some treatments that are actually creating challenges for it, and so these have been set up as kind of a negative and a positive treatment, so that you can consider using them where it's applicable. For design 2, this group showed up. Now, if we were to change it to say design 1, just to show how dynamic this might be, then it shows this design 1 is a very conservative one, and so it looks like there's a lot of positive values, not much in the way of negative. But we just look at existing. Here's one where you can see some on the left and some on the right. Some have an adverse effect and some a positive effect. I will point out that this is the ratio of the effect as it relates to the standard option. So, for example, if I chose the standard option, which is based on standards, I would expect this to have a value of 0 because it's a ratio to itself. And similarly, if I were to choose optimal, I would expect that to be all to the right, because optimal should always be greater than standard. If I were to change this back to design 1, another thing to note is this column that I mentioned earlier we may want to hide. You'll see it has design 1 displayed. It's a dynamic column, so it's been updating. Every time I change this, that's been updating. So, exactly, there's the standard, and it updates for that. But below these pictures, or our vortex, you'll also see that we have just a very, very simple schematic. It also has a similar dynamic adjustment for the title and for the text. It demonstrates what the values are. So here you can see that this shows you your dimensions. It shows you the widths that are assumed. For design 1, this looks like it's a pretty conservative design. If I were to change to design 2, that would then show the values that are associated with design 2. This is not intended to be anything other than just a helpful tool that maybe you might have a snapshot of, just to remind yourself what the assumptions were for the dimensions. So this particular cross-section is design 2, or excuse me, design 1, and so below it, it summarizes the values for design 1, which had an optimal or overall score of 86 out of 100. These values would be consistent with what we see or what we saw in the table. So the overall safety score, as an example, for design 1, if I were to go back to our Start Here tab and look at design 1, the overall safety factor, you can see for the first segment, that's a value of 86. And because all of these are set to configuration 1. All of them right now are 86. But recall that we can then go in and change these values. So let's say, for example, this tab needs to be configuration 2 because maybe I have something different about configuration 2. Maybe it's just a simple thing, like maybe, I don't know, it has very narrow shoulders in the design 1 option, let's say. Make something up. So let's say that it only has 2-foot shoulders in the design 1 option. And so we change that. If you were to come back to start here, you'll see that for configuration 2, the score should have made some change in the existing, which is I think where I changed that. And you can see the same thing with the design 1. I guess the existing and the design 1 value. So these values are just a summary of what are included in the individual configuration files. So that concludes this particular video. Now, there is another video that if you want to check out, just kind of walks you through a sample problem. Thank you.